Hello and welcome to another video lesson. We are in chapter 4.2.1 and we're going to get started here, and I'm going to get my whiteboard set up real quick. All right, so we're going to start with 4.2.1. We want to make sure we take good notes because we want to obviously make sure that we have these notes for our test because this is going to be very important. 4.2.1, proportional relationships are going to be on the test. Proportional relationships. All right, so this is what we're going to be doing today, and I want you to follow along. Make sure you write these notes and make sure that we do a good job here. So 4.2.1. Basically, let's say you see a sign that says you buy 2 pounds of apples for $1.29. Well, how much would it cost for 6 apples? Basically, what you do is you have the 2 pounds, you multiply it by 3. But if you multiply the 2 pounds by 3, you have to multiply the price by 3 as well. So what we're going to do is we are going to go ahead and take a look at our, can't see for some, there it is. We're going to take a look at our problem, 4.2.1. And we're just going to talk about this problem real quick. 4.2.1. Going to write that there. You can also write it over here if you'd like. That's fine. We had this problem 5 years ago. 5 years ago, Gustavo's grandmother put some money in a college savings account. That's going to pay simple interest. After 5 years, so 5 years later, it's now worth $500. Gustavo predicts that if he does not deposit, which means put money in, or withdraw, take money out, then the account will go to $1,000 5 years from now. How do you think Gustavo made this prediction? Well, from the start, I mean, whatever the money is, it started somewhere. I'm going to say 0 right now. After 5 years, it went to 500. Well, then in 10 years, which is plus 5 more years, it should go to 1,000. Well, Gustavo basically thinks he's just going to double his money. He thinks it's just going to double every 5 years. And that's not the case. Well, so I think that Gustavo, and please try to write as much wide as possible. I don't have that much room over here. Well, I think that Gustavo doubles his money every 5 years. He thinks that it's going to double every 5 years. Do you agree? Go ahead and write whether you agree or not. But for B is no. I don't think his money will double. All right, I just don't think it will double. That doesn't make sense. If you know a bank account that is going to double your money every 5 years, you let me know, and I will put in like $1,000 or $10,000 into that account, and we just double every 5 years, and then we just live graciously. But that's pretty much 4.2.1. We're going to make this real quick because I want to make sure that we can utilize our time wisely. So we're going to say this is 4.2.2. So last week Gustavo got his bank statement, and he was surprised to see a graph that showed that although his balance was growing, the bank predicted that in 5 years, his account would only be $600. What is going on? Why is my money growing the way that I thought it would? Well, we want to talk about why is the money not growing like you think it would? And the reason why, well, why might his account be growing in a different way than he expected? Basically, his account is growing and it's getting big. Well, pause it, you can figure it out. But basically, his money is going to be growing at a steady rate that is not doubling. It's going to be lower because he thinks that he's going to earn $500 in 5 years, but he's probably only going to earn $100 in 5 years. So he got some money. So let me go ahead and write this out. So 4.22, he got some money, and we're going to put it X, and then 5 years is going to be $500. But then in 10 years, which is plus 5 more years, it's going to be $600. So it's still a good amount. Its money is growing, but unfortunately, in 5 years, it's only going to grow. In 5 years, it's going to grow $100. And this is where we want to get to talking to our proportions. Here's our plus 5. Here's $100. So if I'm going to make $100 in 5 years, how much money am I going to make every year? Well, you just do 100 divided by 5. 100 divided by 5 is going to be 20 for every year. And this is kind of just like an example of how we're going to be writing tables. X and Y. In 5 years, it's $500. In 10 years, it's $600. What is the change? What is the change on both sides? Well, we know it's going to be $100. That's the change. And then 5 years. So that means the change is $20 per year. So this is a good beginning to what we need to figure out in terms of our tests, in terms of our tables and graphs, because we are going to be doing 3 things: tables, graphs, and equations. And we want to make sure we get them all together. All right, let's go to 423. Let's keep building on this little graph here. So 423, so cross that out, 423. Gustavo decided to look more carefully, and now you see that you have this table here. He put together this table below. So we have time in years. So we have time, and we have our balance, right? And then time is in 2 years, 3 years, 4 years, 5 years. And then we have 440, 460, 480, 500. Remember, after 5 years, it goes to $500. After 10 years, it goes to $600. So make sure you understand that. So for A, and yes, you copy the table down. Please copy the table down. All right. How has Gustavo's bank balance been growing? So as you can see, it's been growing plus 20, plus 20, plus 20. His account has been growing every year. Year, $20. I gotta move this up a little bit. Come on, move up. Has been growing $20 per year. All right. B, does Gustavo's money seem to be doubling as the number of years have been doubling? No, it hasn't. His money hasn't been doubling, which he thinks that it's going to be doubling. So like from 2 to 4, he thought it was going to be 440, and then it would be like 880, which is not the case. So for B, no. His money doesn't double. Every not 2 years, every time it doubles. Every time the years double. I was trying to figure out how to say that, but I apologize. All right, going on to C. Is the bank's prediction a mistake? Banks don't make mistakes. I mean, if they do, they're definitely in their favor and not for your favor. So, no, the bank did not make a mistake. The bank didn't make a mistake because they are giving you $20 every single year on your money. And by the way, that is not going to do very well for you. If you like money, don't put it in a bank. You got to put it in somewhere else. You will lose money the more you save it. You have to invest it, and don't invest in a bank. It's just a terrible investment. All right, I can talk about money all the time, but no. So basically, no. Is the bank's prediction a mistake? No, the bank is giving $20 per year. No, it's not a mistake. All right, 424. Once Gustavo saw his balances written in a table, he decided to take a closer look at the graph from the bank. to see if you can figure out where he made the mistake in his prediction. Find the graph at the right here and use it. Well, you can use this or use the student e-tool Desmos or Decimal. All right, so here is the graph right here. This is the graph. So we want to take a look at this graph and we want to copy this down. And there is additional information about Gustavo's account that you can tell from the graph. For example, what was his starting balance and how much? So let's go ahead and put this in 424. Was it 424? Yep, 424. We're going to copy this graph down. And so this is going to be, I'm going to make this a little bit bigger. And I'm going to delete this. All right, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So every line is going to be 100. And this is 1,000. And then 300, 400, 500. Yes, you need to make sure you write the table down. This will help you on the test. And this is our balance in dollars. And the bottom, we're going to go 1, 2, 3. And I'm going to skip a line just so we can have some space. 6, 7, 8, 9, 10. So 1 year, 2 years, 3, 4, 5, 6, 7, 8, 9, 10, 9, 10. All right, now we have this graph. If you notice, this is a point and it kind of steadily goes, and they know after 5 years it's going to go $500, and in 10 years it's going to go to $600. So as you can tell, this is what the line it looks like. Now it's not very steep. It's kind of flat. But I'm going to say that this is 0, 400. This point is 500. And this one is 10, 600. Now realize that these points actually represent the graph. The bottom here is time in years. And know that this bottom is our x. This is our x here on this bottom level. And this y is here on this top level. So that means our y is our balance and our x is our time. So what we're going to do is we're going to answer these questions. So what is the starting point? The starting balance, well, what do you think? What do you think the starting balance was? $400, because this is 0 years. Right there is 0. So we want to say 0 years, we got $400. $500 in 5 years, $600. All right. So then, how much does it grow in 5 years? It grows $100 every 5 years. All right. Gustavo had to assume his money would double. What would the graph look like if it was true? Use a different color. Someone use a different color. He thinks it was going to be at 400. And then he thought it was going to be, he thought it was going to be like 5 would be 500 and 10 would be like 1,000. So I'm going to go ahead and put that. So if I did a line here, that would be kind of like what his graph would be looking like. And it would be kind of steep. But it would mean it would be low. It'd be really low. It'd be down here almost to 0, which doesn't make any sense. Is it possible that Gustavo's account could have had $0 in 0 years? Why or not? It can happen. It cannot happen at all because his grandma put money in. So that's the thing we want to say. So B is blue line on the graph up here. And then C is no. You start with money. All right. All right, and then 425. I'm going to go ahead and pause real quick. So just know that we have 2 lines. The blue line is what he thought was going to happen. He's going to start at 0 and make $1,000. Yeah, right. And then the red line is regular.